Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline, you'll need somewhere to deploy it, so you should check out Linode. With private networking, shared block storage, node balancers, and a 40 gigabit network, all controlled by a brand new API, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode to get a $20 credit and launch a new server in under a minute. And go to dataengineeringpodcast.com to subscribe to the show, sign up for the newsletter, read the show notes, and get in touch. Your host is Tobias Macey, and today I'm interviewing Joe Crobak about his work maintaining the Data Engineering Weekly newsletter and the challenges of keeping up with the data engineering industry. So, Joe, could you start by introducing yourself?
Sure. I'm Joe Crobak. I have been a software engineer for the past decade or so, mostly working at startups in New York City. And more recently, I've worked for the federal government, U.S. federal government, at the United States Digital Service, based out of Washington, D.C. And my experience in industry is in the big data space for the most part, as well as server-side, service-based APIs and DevOps and things along those lines.
And how did you first get involved in the area of the big data space and data management in general?
Yeah, so that actually dates all the way back to my undergrad CS degree. I was working with a professor on graph algorithms and got involved in a project at the national labs in New Mexico, working on a Cray supercomputer. And this was over a decade ago, and the server had 40 gigabytes of RAM, which was kind of revolutionary at the time and able to run tens of thousands of hardware threads in parallel. And so that was kind of my first foray into big data, and it's where I became a little obsessed with trying to make things run faster or debug complex systems. And then more professionally, I was working as a Java developer while undergoing a master's degree in parallel. And I did a project in my grad program where I used Elastic MapReduce on Amazon Web Services to build a recommendation engine. This was back at the days of the Netflix recommendation challenge. And that ended up lining up pretty well with some work I was doing at the time for an ad network that I had gone to as part of an acquisition. And at that ad network, I was on the team that was responsible for our ad operations, ad optimizations, and I ended up being pretty heavily involved in rolling out our Hadoop cluster, both Elastic MapReduce and later Cloudera running in Amazon Web Services. And most of the team, I would say, was focused on the ad optimization algorithms, and me and a few other people were doing DevOps, things like Puppet, making sure we had a good, solid workflow engine, rather than just cron running at a time schedule. This job starts at 1 a.m., this next job runs at 4 a.m., even if the first one failed, that kind of thing. So it was kind of that confluence that got me into big data and data management, and worked on similar challenges at a few other startups after that as well.
It's always interesting seeing the breakdown of engineers, of the people who are perfectly willing to manually set up a system, hand tune it once, and then just walk away hoping that everything stays running, versus the people who want to fully automate everything and ensure that you can destroy it and rebuild it at a moment's notice without having to worry about any failures in the system by doing destroy and rebuild cycle over and over until everything works.
Yeah, I kind of I like both of those. So it's always nice to be able to destroy and rebuild things from scratch, but also spend that time up front to automate it so that when it comes time to put something into production, you don't have to sit there and handhold it or throw it over the wall to someone else to figure it out.
Right.
I like to try to automate myself out of a job as much as possible in whatever project I'm doing.
Yeah, it's nice having that confidence that everything's going to work right if you need to start all over again. And as you mentioned, you were recently working with the US Digital Services, and looking back through some of your blog posts and your postings elsewhere, I noticed that you were involved with the healthcare.gov site and then later working with Medicare systems. So I'm wondering if you can just talk a bit about your experiences there, particularly as it pertains to the ways that you were managing sensitive data and ensuring that it was receiving appropriate levels of protection.
Yeah, absolutely. So the short kind of setup there is that I was working at a startup in New York, and as these things go, we ended up shutting down, and I was looking for a job with high impact, especially given the fact that I was at a startup that had been pre-launch and needed, it was one of these startups that had a good mission, and I was really excited to see our product get to market, and that never happened. So I ended up working at the digital service and first at healthcare.gov as a federal government employee. I mean, most of the people on that project are contractors, are vendors working for the government, and worked on that for quite a few months when I first joined. And then ultimately worked on a Medicare modernization effort, this program called the Quality Payment Program, which is all about shifting the way that healthcare pays doctors, puts more emphasis on quality rather than volume. So rather than getting paid 10 times for 10 x-rays, your doctor gets paid based on your outcomes. Do you stay out of the hospital? Do you get healthier faster? And so most people are probably pretty familiar, but there's tons and tons of data in healthcare. And these two programs have very different types of data. Healthcare.gov is mostly consumer data, applying for health insurance and providing the information necessary to do that. And the Medicare system is much more health level data. So claims data about when someone goes to the doctor and the doctor ends up billing Medicare, as well as information about doctors themselves. Because the government and most health insurers want to make sure that a doctor is credentialed and that they are up to date and all those types of things, and are not committing fraud. So there's lots of sensitive data in both of these systems. There, as is common in a highly regulated industry, there's a lot of compliance. The federal government likes to take it to a whole nother level. I think we've got these 500-page risk management frameworks that come out of NIST, and a lot of times that ends up being a big paperwork exercise. It's things like how often do you patch your system, or even things like how are you suppressing fire if there's a fire in the data center. And I think what's much more interesting to me as a software developer is how do you design a system to be secure and keep people's data safe. And there are a lot of things you can do along those lines. I'll talk about, I guess, one thing that I think was pretty interesting that we did for Medicare systems. So this was mostly with provider data, which a lot of doctors who are providers, they have a LLC or a small business, and they're billing Medicare using their social security number. So you've got social security numbers in the system. You have to keep those safe. You don't want them to propagate everywhere. And there's a couple strategies. And one of the best ways that you can avoid leaking data is to isolate it to as few systems as possible. And the way that we did this was to introduce what we called a link key, which is essentially just a random ID that's generated and matched up to a social security number, and then you will isolate the social security numbers only to the system that need them, and everywhere else in the system you just use these opaque link keys. And now you just have one system that you need to protect really well, and then the other systems you don't have to worry about logging and all the other types of things that can propagate this PII. In practice, it turns out that can be a really hard thing to do. We didn't get nearly as far down that path as we wanted to. One of the things that we did instead was undergo threat modeling sessions with the teams. And so this is where you get a group of smart people together. You think about all the data systems, you think about all the APIs, and all the bits you're shuffling around between systems, and you kind of look at it with an eye for where things can go wrong, where data could be corrupted, where data could be leaked, and you come up with threats. You think about actors, you think about the sensitive pieces of data in your system, which may not be social security numbers. In some cases, it could be credentials to another system, maybe your login system, things like that. So we would undergo these threat modeling exercises. At the end, you get a big list, and you're able to rank it based on how risky each of those are, and you're then able to start more in a more methodical way, harden your system to those types of attacks. And so I would say that that's an evolving process, one that you have to do continuously. And I'm not the best security expert, but we had some really smart people on our team who were able to drive that process and really improve the security posture of our systems.
And on the healthcare.gov side, one of the initial issues that it had at launch was that the way that the system was architected, it wasn't able to handle the sustained load of all the people who were visiting the site in a short period to sign up for it. And I'm not sure at what point in its life cycle you got involved, but I imagine that there was some work necessary to re-architect the way that the data was received and processed and managed. So I don't know if you can speak a bit to the resulting architecture that you settled on to make sure that it was able to handle the load that it was subjected to.
Yeah. So when I arrived at healthcare.gov, it was the third open enrollment season, and I had read the news articles and thought that everything was fixed. And boy, was I wrong. Fast forward 2 years further down the line to this past fall, and the team really did solve a lot of problems and make the system more resilient. But going back to when I arrived, we showed up and started to get familiar with what was going on, and the system was using a lot of technology that I was not familiar with. So, or let me say that it was the enterprise version of a lot of technology maybe I was familiar with. So an example of that would be Apache Web Server. Instead of, HTTPD that you're installing off of a Yum repo or something like that, we were using the enterprise Apache JBoss server, which bundles its own version of Apache and then talks between the Java web server and the Apache process using a custom protocol. So I show up, and immediately one of the systems that catches everyone's eye, if you are able to kind of, once you're able to wade your way through the hundreds or thousands of servers that are part of the system, is the database engines, the storage services. And the two main ones are a system called MarkLogic, which is a distributed database centralized on or built around an XML data model, or XML processing, I guess is a better way to say it.
That sounds terrifying.
It is, and it gets more and more terrifying because the way that the application servers interacted with this XML database was pretty inefficient. And to put some context on it, the way that the system was designed was that it kind of kept a change log for auditing purposes of all the different things you did as part of your application for health insurance. And you think about representing that as XML, it starts to get big pretty fast. In fact, I've been told that there were bugs along the way where people would end up with 100 megabyte documents because there were some quadratic bugs in adding entries into the changelog. But even without those bugs, you're talking about documents that are maybe in the hundreds of kilobytes or even up to a megabyte. And not a fault of the database, but the way it was architected, the ORM that was doing these, well, I guess it's not a relational mapping, but the mapping from Java objects in the app server to XML really only supported or was only implemented one way, which was to take an entire XML document, take that and serialize it into a Java object, add a new entry to the changelog, and then serialize that back to XML and put it on the wire back to the database. So immediately you're saturating your network. You're sending hundreds of kilobytes of data for every click on the website across the network. You're then writing that to disk, doing lots and lots of disk I/O. Of course, Java is doing all these translations. You're pegging CPU, and you're also exhausting memory on your app servers. So the hardware footprint to handle this system is kind of large for the requests per second, the queries per second it's supporting, and it's very close to kind of falling over. Any little perturbance in the force will kind of cause everything to cascade, and so many moving pieces because of the way the system was designed to match the government's technical reference architecture. There were JMS queues in between systems. There were load balancers on load balancers on load balancers. I think I counted at one point in time there were 8 hops before you got to the app server within the data center. So you're talking about lots of complexity and lots of and it becomes really easy to make the system fall over. And on top of that, of course, you have lots of batch processing to do on the back end. A lot of the ways that the healthcare system works, you get people in who are enrolling on healthcare.gov. Well, that there has to be some translation then of sending those applications over to the insurance companies. So that was done via nightly batch jobs. And you had to then copy data out of this MarkLogic cluster eventually into a Hadoop cluster. And you ran into all kinds of issues where batch jobs would stack up on each other, and no one had very good visibility into what was running when and what team was running things, because you're talking about dozens, if not more, contractors working on this system and trying to coordinate with each other. And it's a little bit of a chaotic setting. So a lot of what we did the first year we were there was just try to understand who the key players were, get an inventory of who was pressing what button on what batch processing that was happening. That, unfortunately, it was a lot of the batch processing had to touch the production system, and try to get out ahead of some of these issues. We also, of course, did things like balancing the cluster to try to eliminate hotspots. But as you can imagine, with a service that's kind of pushed to the max, and you have a situation where one node on the cluster can kind of bring down the entire system if it gets taxed too hard. So I think the way that a lot of these issues were resolved, unfortunately, the timelines to do new development didn't allow us to completely re-architect it, and it's one of these things where I think some of us who came in from industry pitched something that was much more aggressive in terms of re-architecting and taking load off of this XML database and onto a more traditional relational database that could probably handle the load perfectly fine. But ultimately, the people involved decided to more or less stay the course on the architecture and make changes around the periphery. So they really got these batch processing issues under control. They were able to work with the database vendor to fix some scary distributed locking problems that would take the website down to make it much more stable. And they are, I believe, 2 years now into a project to kind of API a lot of these systems so that they can, once they have an API instead of this monolithic Java app, they'll then be able to start to peel pieces off of the current database and put it onto something new. So lots to unpack there, but it's certainly interesting and eye-opening, and a architecture that probably none of us would design, but kind of something that was shoehorned into a design by committee type situation.
Yeah, it's always interesting being exposed to some of these types of architectures where, coming from a perspective of all of these open source options and massively scalable systems and sort of community advocated best practices for doing things and going into something that does have that more stringent and structured requirements of everything needs to be able to match to a certain specification, and that will eventually mutate the actual technical architecture, and seeing the things that result to give you an idea of what is actually possible when you are forced to work within certain constraints.
Yeah, absolutely. Although, as I've told some of my friends who work for some of these open source vendors, I think the government is a great customer to have, because they're not afraid to use open source. They're afraid to use open source without a vendor contract. So I think if you can get your product in front of the right people, you have a good opportunity to bring some great technology to solve hard problems in the government, but also there's a lot of money in it, because the government wants to make sure they have someone who's accountable for every system in the program.
Yeah, it also talks to the requirement for long-term sustainability of some of these projects, where we have new database systems coming out every month and new ways of processing data and streaming pipelines, and it's all very useful, particularly for organizations that are moving quickly and are able to implement these new technologies. But for a system where you have a mandated time horizon that's potentially in the measured in the span of decades, you need to be very careful in the choices that you make for technology to build and support these organizations and these platforms.
Oh yeah, absolutely. On the Medicare side, much of Medicare claims processing runs on COBOL mainframes that were implemented in the 80s. And good choice. There's still a lot of mainframes in the world, believe it or not. But that's becoming a problem, because it turns out it's hard to find COBOL programmers nowadays. But these systems were designed and have lasted 40 years, and they're sitting there processing data that pays out trillions of dollars. Medicare itself is 3.4% of the U.S. economy. So sometimes old or boring technology can be the right solution.
Yeah, there's a lot of discussion, particularly in operations, where you having boring systems is a good thing, because it means that you can sleep well at night knowing that you're not going to get paged with a system failure because you have some new unproven technology that's being used in production.
Yeah, I agree on that. Of course, no one wants to be the one maintaining a 30-year-old system either.
Right. And now, in the process of your work, getting involved in these large data processing systems and working with Hadoop, you somewhere along the line decided that it would be a good idea to start a weekly newsletter detailing some of the technologies and articles pertaining to the Hadoop ecosystem. So I don't know if you can speak a bit about your decision that led you to wanting to start with creating that newsletter.
Yeah, so as I was saying when I was kind of doing my introduction, I kind of fell into the Hadoop, the big data ecosystem, just through being at the right place in the right time, like I think a lot of people were. And I was feeling overwhelmed with how much was out there and how many products there were, how many, even it seems like it's exploded exponentially, but at the time, Hadoop distributions had 6 or 7 different components to them, and so my solution to that was to try to read as much as I could. I was following every blog I could find, whether it was a big vendor or LinkedIn or Twitter. I was reading academic papers that teams were putting out, and really trying to absorb everything I could, so I could feel like I had my head above water to stay on top of the industry. And also, I kind of turned a page at some point where I was solving problems when I was working at Foursquare, and I knew that other people had solved these problems, so it turned into more of a, how do I apply what other teams are doing to the problems I'm facing? And so I found myself reading 20 or so articles a week probably. And at some point, I would send a couple around internally on mailing lists with a short summary. at some point I said, well, I'm already doing all this research and seeing all these articles. I'd been a big fan of a couple of other newsletters that were out there. And I said, well, I'm already doing this. Why don't I just turn it into a newsletter and see if other people are interested? And that was how Hadoop Weekly was launched on inauguration day of President Obama's second inaugural back in what was that, 2013.
That's funny, the timing, so that you have a anchor point that you can remember it by, after many years have gone past.
Yeah, that was
that intentional timing or just coincidental?
It was coincidental. I had to get the domain name and the MailChimp account and all those things, and I probably did that over Christmas break, and that was the coincidental timing. But I just celebrated 5 years, and when I looked back on it, I said, wow, funny timing, and kind of relearned that it was the inauguration day. And yeah,
that's funny. And a few months ago you wrote a post detailing your decision to actually rebrand Hadoop Weekly to be Data Engineering Weekly because the space has expanded so far beyond just the Hadoop ecosystem. So I don't know if you want to just briefly cover your decision around that.
Yeah, I think there are a couple main motivators. Data infrastructure, data engineering have become, well, let me say that I guess most people are not just using Hadoop. They're building all kinds of products with and around Hadoop, and we're starting to see tons of other products, open source or closed source. But really, there's been like this just momentum shift to things like Kafka and Spark and Flink. We've also got NiFi and Kubernetes. There's been a big push to the cloud, which lets people experiment with these other tools, unlike when you're kind of in a fixed data center. So we're seeing a lot more adoption of different tools, and along with that, a big emphasis on real-time and stream processing. So when I started the newsletter, I mean, you had your big companies like Oracle and IBM, but in terms of open source software, just about the only enterprise companies out there were selling Hadoop, and I guess you also had DataStax selling support for Cassandra. Now you have companies around all these different things, and so I found it more and more interesting to focus on things around Hadoop, how you integrate with legacy systems, how you get data into a serving layer to actually build a product based on the data science that's done on your Hadoop cluster, how you manage the data workflows. And I think the tooling and the ecosystem around Hadoop has matured. A lot of it has caught up with kind of the tools that existed in the relational database world before Hadoop was a big thing. And it's become much more interesting to focus on those things than Hadoop, which now has matured and is kind of moving a lot more slowly.
Yeah, it's starting to become one of the quote unquote boring systems that just, sits there and reliably does what you tell it to, and you don't have to keep paying attention to it to make sure that everything's running as it's supposed to. So it isn't generating as much press, except for when they make their occasional releases with new features. And beyond that, it's just become part of the background and, some of the part of the day to day.
Yeah. And I think also, you're absolutely right on that. And it used to be that you had things like Elastic MapReduce, and you could get a Hadoop cluster up, and maybe it could run Pig or Hive. But now there are just so many tools to launch other things and get things up and turn them into boring technology too. I think that's a good thing. I've operated Hadoop and some of these other tools along the past couple of years, and there was a long time where they weren't boring, and I'm glad to see things mature. But you always have that balance where things start to mature, and then you start to see less innovation.
And in order to generate a new newsletter every week, you must be reading through a lot of articles and keeping track of a lot of different projects as they iterate, and watching videos. So what is your sort of workflow for being able to keep track of all of the different things that are happening in the data engineering ecosystem?
Yeah, so it's changed a little bit over the years. I think at this point, I get a lot of my news kind of pushed to me. I've curated a couple different channels, whether it be mailing lists or the folks I follow on Twitter or the, accounts that I follow on Twitter. I have a throwback where I'm following a bunch of RSS feeds of different companies or blogs out there. We More recently I've been focusing a lot on Medium. It seems like that's where a lot of people tend to publish or cross publish their posts. And so I have kind of this deluge of data that's coming at me throughout the week, and I bookmark interesting articles when I see them. Usually don't get a chance to read everything until Saturday or Sunday, the weekend, when I'm actually compiling the newsletter. But that's kind of the current state of things. It used to be that maybe there was more emphasis on Twitter. At one point in time, I had written a script to go and find all the Hadoop related posts out there, deduping against stuff I had already seen. That turned into a war between me and the people posting Hadoop related jobs on Twitter, and ultimately they won. So I kind of gave up on that script. But I try to evolve with the communication channels, and they definitely have changed over the past 5 years. But kind of the mailing lists and Twitter and have been the two mainstays, and even things like RSS feeds and Medium have been a little bit more recent.
And as you're going through all of these different posts and articles, etc., are there any particular questions that you ask of yourself and about the content to determine whether you want to include it in a given issue? Or I'm curious if you have a particular sort of focus or purpose behind the ways that you are selecting these different pieces.
I try to, for the most part, anticipate what my readers would like, and I have to admit that that's kind of an informal feedback loop. I do hear from people occasionally. I probably hear more from people that are liking what I'm curating than what I'm not. And so the main question that I get at, or the main way I try to answer that question is just, do I like the article? And if there's an article that I feel like I'm getting bored, or maybe it's not making sense, maybe I'm having trouble following the post, a lot of times I will try to do some background research. But if it becomes something that it turns out I'm not interested in, then that's kind of the first strike. And my background is much more on the, as we've talked about, the data engineering, the back end, the DevOps side. So that is what I tend to cover, and probably a little bit on what maybe people would call machine learning engineering. There was recently a post covered in my newsletter, and I can give you the link for the show notes, called the flavors of data science and engineering, and it was kind of this 8-circle or 9-circle Venn diagram of all the different roles and how they overlap, and I think the articles that I cover are pretty squarely in the data engineering, backend, DevOps side of things. And that kind of is the high level way that I narrow it down. There are a couple other filters, and I say filters because honestly, every week I start out and I probably have 40 or 50 links that I'm evaluating to include in the newsletter. And if you post an article, you could also just get really unlucky where there are 15 or 20 other really good links that week, and yours kind of fell off. But the other filters I use are, if I'm reading something from a vendor, is it just a vendor sales pitch, or is there something technically interesting in there that maybe is not vendor specific? I look for, is this blog post just a regurgitation of the documentation for the tool. So you'll see a lot of people who maybe they went through and just set up Spark or Hive or something for the first time and wrote a blog post about that. And sometimes they find something new and interesting, but a lot of times it's almost exactly the same steps that you would find in the tutorial on the website. And then kind of on the other side of things, you sometimes find these really niche articles that are about a tuning option of a proprietary database, and they just tell you what the option is and how to set it, and they don't really tell you what's happening under the hood. And those kind of niche ones that are the ones that'll also get filtered out. I try to cast a wide net and be fair. I think I'm following most of the major vendors and some smaller ones on my RSS feeds. I have gotten some flack in the past when I, not on purpose, but inadvertently maybe missed a big blog post from one of your favorite vendors. I'll get some angry emails. So I try to give everyone credit for all the hard work they're doing and include them in the newsletter as much as possible.
Yeah, it's difficult being the person who is, in some case responsible for providing a lens on the industry. As somebody who's producing a podcast on the space, every time I go to my list of interview ideas, I have to look at it thinking through, is this a topic that is going to be interesting enough to talk about for 45 minutes to an hour? Is it something that I'm going to learn something from, that my audience members are going to learn something from? As you mentioned, sometimes you have to be concerned about, is this conversation just going to turn into a vendor pitch without enough technical aspects to it? So it's always challenging to try and think about things beyond just, is this something I'm interested in, and figuring out whether or not it is more broadly applicable to the people who are subscribing to your newsletter or my podcast or things like that.
Yeah, and I think this is probably a call out from both of us. If anyone out there has feedback for me, I always love to hear it. I'm reachable on Twitter. You can email info@dataengweekly.com. I'm always open to feedback, or if you have articles to send my way, I love to get proposed articles from folks out there. And then, Tobias, maybe that you and me should form a support group to help review each other's.
Absolutely, yeah. Having to have that deadline of every week I need to release a new episode, it's often difficult to keep track of something new and interesting for the week. So I'm always happy to get input on suggestions for show ideas or feedback on past episodes of what went well or what didn't. So as you mentioned, having that feedback cycle is very helpful, and particularly with podcasts, it's often very asymmetrical of, I publish something, somebody consumes it, and that's the end of the interaction. So closing that loop every now and then is very useful.
Yeah, absolutely.
And having worked on curating the newsletter for the past 5 years, I imagine that there's been a lot of back and forth in terms of influence, both from your interest on the newsletter and from the newsletter on shaping your particular interests. So I don't know if you want to talk a bit about that and how it has sort of led you in your current thinking of what your plans might be going forward.
Right. So I have nearly stopped publishing the newsletter a couple times here. It is a lot of work. I enjoy doing it, and ultimately have made a pretty big investment going forward in trying to make it work. And I think the big reason that I've done that is my professional career has kind of shifted. So I used to, as we were talking, work pretty in the weeds on a lot of the big data technologies. I was deploying Kafka, deploying Hadoop, HBase, all these tools, working pretty hands-on with a lot of DevOps. And then when I went to work for the government, my role was very different. It was mostly to be the technical voice in the room, to set expectations with executives that, no, really, we don't need to spend $10 million on a data center to run a web app that's going to see 10,000 users a month or something like that. So the newsletter has been a way for me to stay connected to the industry that I very much enjoy. It gives me ideas for side projects all the time, and sometimes I get to work on those. A lot of times I don't. But my interest and relationship with the newsletter has definitely evolved over the years. It's much more kind of a outlet for me now to get more technical and to occasionally read a more academic paper that's probably pretty dense and in the weeds, but also see what tools are out there and stay on top of that as things evolve. My current excitement is with the shift to things like stream processing and having the tools like Kafka, like Flink, to really be able to implement some of these patterns that have existed for a while, like the CQRS and change data capture, concepts that have been around for a while, but we haven't really had good tools to implement them. And so it's been really exciting to see, those go from a blog post by Jay Krebs about the log to people are now actually building systems like at the New York Times based on these types of concepts and these architectures that are not necessarily novel, but are enabled by this shift in the tools that we have a lot for the first time.
All right. And are there any other topics that we should discuss further before we start to close out the show?
I think we covered a lot, so it was good.
Okay. So for anybody who wants to get in touch with you or subscribe to the newsletter or follow the work that you're up to, I'll have you add your preferred contact information to the show notes. And as a final question, from your perspective as somebody who is keeping up with the data engineering space, what do you see as being the biggest gap in the tooling or technology that's available for data management today?
I wish I had a really good answer, an insightful answer to this question. I think that the thing that's been most striking to me on the data infrastructure tooling, and probably the most frustrating as well, is that we seem to always have 2 or 3 or 4 tools to do the same job. A prime example of that is workflow engines, and all of them do it kind of okay, but nobody does it really well. And I do think we're starting to see some consolidation, but a lot of the vendors have their momentum behind one tool and not the other. So hopefully we'll start to see some more consolidation, because I do think that's an area where we'll start to see vast improvements if you have people working towards the same goal instead of on the same software project instead of multiple software projects functionally doing the same thing.
All right. Well, thank you again for taking the time today to join me. I have been subscribed to your newsletter for at least a few months now, and it has been very helpful for me as I try to find topics for the podcast. So thank you for that. Keep up the good work, and I hope you enjoy the rest of your day.
Thank you, and thanks for having me. It was a lot of fun.